Friends, in this video we are going to have an introduction of very interesting topic. Name of the topic is rational algebraic expressions. Now you will say, sir, please explain it. There are three words. Okay, let us see first rational. I hope all of you are aware what is meant by rational numbers. Recall it. Rational numbers are numbers which are written in the form of numerator upon denominator. For example, 75 upon 25 is a rational number, right? So rational number which is written in the form of numerator upon denominator, and denominator is not equals to 0. Okay. Expressions contains more than two numbers with mathematical operator like the 75 upon 25 multiplied by 30 upon 45. So this is an expression, and this is a rational numerical expression because it contains numbers. First is a rational number, second is a rational number. We are multiplying two numbers, means we are solving an rational expressions. Done. Now what is meant by algebraic expressions? Students, algebraic expressions means where algebra is included. Algebra means variable is included, x, y, z, a, b, c, d along with numbers, means in simple words monomial, binomial, trinomial, quadrinomial, polynomials, such things are used in the form of rational numbers. Means if algebraic expressions are used in the form of numerator upon denominator, such an expressions are called as rational algebraic expressions. For example, a square plus 5a plus 6 upon a square minus a minus 12. This is a rational algebraic expression because this is the algebraic expression at the numerator. There is one algebraic expression at the denominator, right? And we are performing some operations on them. For example, we are multiplying this first fraction or first rational number. Yes, ultimately it results into one number. As you will go in higher standard, you will come to know it results into one number, one rational number. Okay, so this rational number we are going to multiply with another rational number like a minus 4 multiplied by a minus 4 upon a square minus 4. So students, this is a rational numerical expression. This is rational algebraic expression. Clear? Now we are going to see how to solve this rational algebraic expression and why the method which we are going to use to solve, why we are using that method only. Okay students, so before solving this rational algebraic expressions, let's recall how do we solve rational numerical expressions. Suppose 75 upon 25 multiplied by 30 upon 45 is given. Will you multiply 75 by 30 and then 25 by 45 and then divide the multiplication of numerator by multiplication of denominator? If you are doing this, you are good. But till that is very aam zindagi. That is not a mentos zindagi. What is the mentos zindagi? Normally we factorize the numerator. Means how do we do it? We factorize this 75. 75 is in the simplest way we say 15 5s or 25 3s. 25 3s means 3 multiplied by 25 means 3 multiplied by 5 multiplied by 5. 5 5s or 25 3s. 75. 30 3 10s means 3 multiplied by 10, which is again 10 is nothing but 2 multiplied by 5. See, 5 2s are 10, 3s are 30, 5 5s are 25, 3s are 75. This is the multiplication of 75 into 30, which we are going to divide by 25 into 45. Means again we will divide this 25 by 25, which is not equals to 5 multiplied by 5 multiplied by 45. 9 5s are 45. Means 5 multiplied by 9 which is nothing but 3 into 3. Okay, and after that what we are doing, we are cutting the same factor from numerator and denominator. For example, this 5 will cut. After that this 3 this 3 will cut, this 3 will cut, this 5 will cut. So what is remain? 2. So 2 is the answer of this total rational numerical expressions. So what we have done, we have factorized the various expressions in the numerator, we have factorized the various expressions in the denominator, then cut the common factors from numerator and denominator. Same thing, students, we are going to use here. Here also we are going to factorize the numerators, then we are going to factorize the denominators, and among the common factors among those we are going to cut the common factors from numerator and denominator. Now the question may arise, how to factorize it? Normally, students, for factorizing algebraic expressions, very few formulae are used. Which are those? We are going to use either a plus b bracket square, which is nothing but a square plus 2ab plus b square, first formula. Second formula, a minus b bracket square, which is nothing but a square minus 2ab plus b square. Third one is a square minus b square, which is equals to a plus b multiplied by a minus b. Right? These three formulae we learned in last year, as well as this year in the factorization we learned a cube plus b cube, which is equals to a plus b multiplied by a square minus ab plus b square. Second one is a cube minus b cube, which is equals to a minus b multiplied by a square plus ab plus b square. Right? Now, students, it's very easy to identify between the given terms and the factors. See, here are in first three formulae, in all of the formulae there are two terms, but in first formula there is square of bracket, in second formula in first and second formula there is square of bracket, in third formula square of two numbers, in fourth formula cube of two numbers with addition of cube of two numbers, fifth formula subtraction of cube of two numbers. Okay, so 1 2 3 4 5 formulae plus the technique of factorizing ax square plus minus bx plus c. What we are doing here, we are multiplying this coefficient a and c, right, and finding its factors such that their additions, finding its two factors b1 and b2 such that their addition or subtraction is equals to b. Okay, this technique means either 1 2 3 4 5 formulae or this sixth technique, or the most common technique is finding out common factor between two terms, which is the most basic technique we have to use while factorizing, is find highest common factor between two terms. Okay, so among all these techniques, whichever is useful we are going to use, and that we will see with the help of this example. A square plus 5a plus 6 upon a square minus a minus 12 multiplied by a minus 4 upon a square minus 4. Okay, students, so I hope you got the idea. The idea is we have to factorize each and every term from the numerator and denominator by using any of these techniques. So let us factorize it one by one. First is take a square plus 5a plus 6. How do we have to factorize it? We have to use this sixth formula, because 5 formula contain only 2 terms, it contains 3 terms, 6 formula also contains 3 terms. So a square plus 5a plus 6. How do we have to factorize it? Multiply coefficient of first and last. 1 into 6, 6 plus 6. Multiplication is plus 6. So we have to find out two numbers such that addition is 5 and multiplication is 6, and those two numbers are 2 and 3. So how we will write it? As equals to plus 2a plus 3a plus 6. Right? Now among this we can take a common. Take a common, so it will remain a into the bracket a plus 2. 6 divided by 2, 3. So among this pair we can take plus 3 common, a plus 2. Now among this pair take a plus 2 common. So here it will remain a plus 3. So here we factorized the numerator of the first fraction, that is a square plus 5a plus 6 is equals to a plus 2 into a plus 3. Okay students, now we have to take the second one, a square minus a minus 12. Now take a square minus a minus 12. Once again, 1, 2, 3, 4, 5 formula contain 2 terms. This formula contains 3 terms and orders of the indices are decreasing. Highest order is 2. So it is perfectly matching with the 6th formula of ax square plus bx plus c. Means we have to factorize it such that multiply the coefficient of first and third. 1 multiplied by minus 12. Multiplication is minus 12. Multiplication is negative. So we have to find out two numbers such that their subtraction is equals to 1. And multiplication is 12. So those two numbers are 3 and 4. 4 3s are 12. Greater symbol of the answer is symbol of the greater number. So we can write it as equals to a square plus 3a minus 4a minus 12. Now among this pair we can take a common. So here it will remain a plus 3. Minus 12 divided by plus 3 minus 4. So take minus 4 common. Here it will remain a plus 3. Take a plus 3 common. So here it will remain a minus 4. So this a square minus a minus 12 is factorized into a plus 3 into a minus 4. Clear up to this? Now students, a minus 4. Can we use the first formula? What is the first formula? Two terms, their addition is there and we have to find out square of the addition. Is it the case addition? No. So subtraction is used in which formula? 1, 2, 3. Let us see among these three formulae which we can use. A minus b bracket square. Is the a in the form of square? No. So we can't use this formula. Third formula is a square minus b square. Yes, 4 is the square of some number but a is not square, so we can't use third formula also. A cube minus b cube. Neither a nor 4 is cube of any number, so we can't use any formula at this place. So don't factorize it. Now what we have to do? Let's come towards next expression, that is a square minus 4. Formula contain minus. So let us see the formula with minus. Can we use the second formula a minus b bracket square? No. Let us see third formula, a square minus b square. What is required? Square of first term and square of second term. First term should be square of something. A square is square of a. B square means 4. Is it a square of any number? Yes, it is square of 2. Means we can write it as a square. Therefore we can write it as a square minus 4 is equal to a square minus 2 square, right? And here we can use the formula of a square minus b square, which answer is a plus b, means a plus 2, which is equals to a plus 2 multiplied by a minus 2. So students, now we have factorized all the expression which are possible to factorize, first, second, third. So let's write it in the final answer. Therefore given term or given expression is equals to a square plus 5a plus 6 is nothing but a plus 2 into a plus 3 upon a square minus a minus 12 is nothing but a plus 3 into a minus 4 multiplied by a minus 4. We didn't factorize, write it as it is, upon a square minus 4 is nothing but a plus 2 multiplied by a minus 2. So we have factorized as we are doing with numericals. Factorization is done. Now what we have to do? Cut the common from numerator and denominator. A plus 2 at the numerator, a plus 2 at the denominator. Cut it. A plus 3 at the numerator, a plus 3 at the denominator. Cut it. A minus 4 at the numerator, a minus 4 at the denominator. Cut it. So what is remaining? At the numerator, nothing is there, means only 1 is remained. At the denominator, a minus 2 is remained. So this is our final answer, because its further factorization is not possible. So students, I hope you got the idea. The idea is factorize the terms, the expressions which are possible to factorize. First thing. Second thing, for factorization, use this 1, 2, 3, 4, 5, 6 formulae, or the technique of finding highest common factors between two terms. Second thing. Third thing, after factorization, cut the common factors from numerator and denominator. Okay. And the most important pro tip, while cutting, cut whole bracket. It shouldn't happen that this a is cut and this a is cut. It's not. You can directly cut whole bracket. A plus 2 directly you can cut. Thank you very much for watching the video till the end. I hope you have understood concept explained in this video. You might have learned something new through this video. Friends, if you have liked the video, please hit the like button, and if you are new to the channel, please subscribe the channel and hit the bell icon. So every time I will upload a new video, you will get the notifications about it and you will not miss any of the concept of this simple subject. Thank you very much.